pencast, we're going to talk about electron configurations. So here I want to put on a periodic table that shows those blocks on the periodic table because it really should be used as your guide, remembering that the D block is 1 level behind and the F is 2. I'm going to use the atom iron as an example. So in order to get to iron, you first need to go through 1s, and even though helium's over there on the P side, remember that's part of 1s, 2 electrons. Then you fill in 2s, again, those 2 atoms, so 2 electrons. Then we start filling up 2p. Remember that p has 3 degenerate or equal energy orbitals, and we're going to fill them with 2 electrons each. 1 arrow up, 1 arrow down. Then keep going because we're not at iron yet. We fill 3s again with 2. We got to still keep going, fill the entire 3p. Again, completely filled with 6. 1 arrow up, 1 arrow down, 1 arrow up, 1 arrow down. Now this is that tricky part. This is how we know 4s comes first. We fill 4s first. And then last but not least, we need D. Remember, D is 1 behind, so this would be 3D. And we need to go 6 over. Remember that the D has 5 equal energy or degenerate orbitals. And that according to Hund's rule, we're going to spread out those electrons before we pair them up. Now, that's an orbital diagram. For electron configuration, you would literally just take those arrows and add them up to make these superscripts. So it would read 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now I'm going to erase and show how you can use the periodic table to do the shorthand or condensed notation. This time again, iron, I'm going to do it in red. You go up 1 row and all the way over to that noble gas column. So we're saying it has all the electrons argon has, and then you just finish up with the trace, okay, of the electron configuration only past argon, so 4s2 and then the 3d6. I hope this helped in giving you another example of how to do orbital diagrams, electron configurations, and condensed electron configurations.